Okay, let's start the exercise 4.5. Actually, we started this exercise in previous class. The last question was that question 8, and we did up to adjoint of A. So we did not discuss about the inverse, the formula of inverse. So now I'm discussing the formula of inverse or the necessary condition whether the inverse will exist or not. So in question number 8 exercise 4.5, we have to find inverse of A if it exists. It's written clearly if it exists. Exist means you should find determinant of A, and this I have done the calculation, so it's coming -3, which is not equals to 0. So if determinant is not 0, that means inverse exists. Or you can see this condition also, theorem number 4, a square matrix A is invertible if and only if A is non-singular matrix, means determinant of A not equals to 0. So our determinant of A is not equals to 0. We have found all the cofactors. In the previous class I explained you how we have found this. So after finding all the cofactors, we found adjoint of A, which is this matrix transpose, and ultimately we got this as adjoint. So that I wrote as an answer, but that was not the inverse of A. Now we'll find the inverse of A. That inverse is the formula 1 upon determinant of A equal to adjoint of A. So the formula will use it. The proof how this formula is come we'll discuss in next exercise, which is 4.6. So now you will use the formula only. So 1 upon determinant of A, which is determinant of A is -3, so this is -1 upon 3, and this is the transpose of this matrix. So this is adjoint of A. So this is how we can find the inverse. We'll discuss now this question number 13. A is given 3 minus 1 1 2. Show that A square minus 5A plus 7I equals to 0. Hence find A inverse. This type is really very important. In exam it normally comes. So hence means not actually you have to find inverse through the formula. Hence means using this equation you have to find A inverse. So let's begin with this. Well, first we'll show this part that this equals to 0. So for that we need A square first. So we'll calculate A square. A square is 3 minus 1 1 2. This is 3 minus 1 1 2. Do the multiplication. 3 9 and 1 minus 1, so this will be 9 minus 1 8. 3 1 3 and 1 2, this is 5. Minus 1 3 and minus 2, so this is minus 5. And minus 1 plus 4, so this is 3. So this is our A square. Now the equation is we'll take the LHS. A square minus 5A plus 7I. So A square we have found, this is 8 minus 5, this is 5, this is 3, and 5A means A 5 should be multiplied by all the elements of this A. So this is 15, this is 5, this is minus 5, this is 5 to the 10, and 7I means I identity matrix should be multiplied by 5. So this will be 7 0 0 7. Now you simplify this. So 8 minus 5, this you can add first. 8 and 7 15, 15 minus 15, this is 0. And now this is 5 minus 5 0, this is 0 minus 5, and this becomes plus 5 0, so this is 0. And 3 and 7 10 and minus 10, this is again 0. So this has come as 0 matrix. Remember this 0 is not 0, this is the 0 matrix. So we have shown that LHS equal to RHS. Now next thing, we have to find A inverse using this equation. So we'll write this again. A square minus 5A plus 7I equals to 0. Now you multiply, or you can say multiply. Pre-multiplication you can also say multiply by A inverse both side. So that multiplication can be of right hand side or left hand side. So we here in this particular case will say this is post multiply. Post multiply means we are multiplying from right hand side. It is not compulsory to mention, but it's for you to understand that what pre multiply and post multiply. So this becomes a square into a inverse. This is minus 5 a into a inverse plus 7i a inverse and 0 matrix into a inverse. You know that 0 matrix multiply by any matrix, answer is always 0 matrix. So this now a square can be written as a into a, this is a inverse, and this minus 5 a into a inverse, because you know a into a inverse is I, and because but we have to see whether this a inverse exists or not. So we can see the determinant. This is 3 into 2 6 and plus 1, so determinant of a is 7. So we can see this determinant of a 7, which is it means that a is non-singular, so inverse exists. So inverse exists, it means we can multiply both side by a inverse. So this becomes I, and this, because I into a inverse is again a inverse, so you can write this a inverse, this equals to 0, and this becomes I. So this is ai minus 5i plus 7a inverse equal to 0. Now from here you can see that a inverse 7a inverse will be 5i minus a. So we'll first calculate 5i minus a. So 7a inverse 5i means 5 0 0 5, and a we have a is 3 minus 1 1 2. So ultimately it's coming now 5 minus 3, this is 2, 0, this is minus 1, this is 0 minus 5 minus 1 is plus 1, 5 minus 2, this is 3. So a inverse from this, it will be 1 by 7, 2 1 minus 1 3. So this is your answer, and it has to be found, this a inverse has to be found only by this method, because it's clearly mentioned hence using this equation. So nobody will find the determinant using the formula method, which is a inverse equal to 1 upon determinant of a into adjoint of a. So that will not be used. Come to this question number 14. Find the matrix A. This is given 3 1 2 1. Find the for the matrix A, find the numbers A and B such that this equation is given to us. Now you can see we need a square, so starting will do with finding of a square. So a square is equal to a into a. So a is 3 1 2 1 3 1 2 1. Now we can multiply 3 3 is 9, 9 2 11, 3 2 6, 6 on 3 2 is 6, 6 plus 2, this is 8, 1 3 1 1. So this is 4 1 2 1 1, which is 3. So this is your a square. We are doing this solution. So now you put a square into this equation. So a square plus a plus bi equals to 0, and you'll get now a square means 11 4 8 3. A means small a multiplied by then a matrix 3a 2a, and this is bi, so this will be b 0 0 b. I'm multiplying identity matrix by b directly here, which is now 0 matrix. So now solve the left hand side. So this becomes 11 plus 3a plus b, and this becomes 8 plus 2a, this is 0. This becomes 4 plus a, this is 0. This becomes 3 plus a plus b, this equal to 0 matrix. So 0 matrix is 0 0 0 0, we will write. Now you have to find the values of a and b. So rather than taking this equation, you can take any two, it never matters, but take the easiest one, because you can see this element 4 plus a equal to 0. So from here a is minus 4, and from this now 3 plus a, or you can take this one also, it's up to you. 3 will do 3 plus a plus b is equal to 0. So we have a is -4, so put -4 plus b equal to 0. So b will be, this is -1, so b will be 1. So therefore a equal to -4 and b equal to 1 is your answer. Remember, this type is really very important. Come to this question number 16, which is I have written very important. From examination point of view, this question is really important. 2 cross 2 matrix, we can ask questions in the exam also, but the chances are of 3 cross 3. So this is of that type. There are 2 types and there is one more type given in the solved example also. So I am doing one, you will be doing the rest 2. So a is this 2 minus 1, 1 minus 1, 2, 1, and we have to find, first we have to verify that a cube minus 6a square plus 9a minus 4i equal to 0, and hence we have to find a inverse. So you see that in the beginning we have to find a cube. So a cube, actually a cube, first we have to find a square. A square is a into a, so we'll write a and then we'll multiply a. So this is 2 minus 1, 1, this is minus 1, 2 minus 1, this is 1 minus 1, 2, and we'll write it again, 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2. See, these questions are easy, but remember this question is, comes into the category of trapping questions. Trapping questions, I explained you many times. Trapping questions means these questions will take you a lot of time. Though the questions are easy, you know what is to be done, but when you start this question and when you will end up this question, you will find that you have used 2 times as you can attempt a 4 marker question. So please be careful of this type of questions. You attempt this only when you are very fast in calculations. Otherwise, better you not to do this if it is in option. If there is another option, try that question. Now we'll find a square. Now we have found a square. This is 6 minus 5, 5 minus 5, 6 minus 5. This is 5 minus 5, 6. Now we have to find a cube. So a cube is actually a square into a. So a square we have found now. This is 6 minus 5, 5. This is minus 5, 6 minus 5. This is 5 minus 5, and this is 6. And a is 2 minus 1, 1, minus 1, 2 minus 1, 1 minus 1, 2. So now we'll find the answer of a cube. So we have found the a cube, which is 22 minus 21, 21 minus 21, 22 minus 21, 21 minus 21, 22. Now our next part of the answer is that we'll verify this. So we'll take LHS. So LHS is a cube minus 6a square plus 9a minus 4i equals to 0. This we have to show. So we'll take a cube. So a cube is, we'll take LHS only. A cube is this 22 minus 21, 21. This is minus 21. This is 22. This is minus 21. This is 21 minus 21. This is 22. And 6a square. So 6a square we have found this value. So now I am multiplying directly by 6. So 6 into 6, this is 36. This is minus 30. If you apply this way, you can save a lot of time. Otherwise you will be ending up with after consuming a lot of time. So do this directly if you can do. This is minus 30. This is 36. This is minus 30. This is minus 20, 30 plus 30. This is plus 30. This is minus 30, and this is 36. So this is 6a square. Now plus 9a. 9 we again multiply directly. 9a will be 9 to the 18. This is minus 9. This is 9, and this is minus 9, 18 minus 9, and this is 9 minus 9, this is 18, and this is minus 4i, so 4i will be 4 0 0, this is 0 4 0 0 0 4. So now you can simplify this. After simplifying, you see that minus 22 and minus 36 and plus 18, this minus 4, this is minus minus, this is 40, and here also this is 40. So this way you can see these two are negative, so this is minus 40, and plus these two are positive, so this is plus 40. So now after do this, the again minus, this is plus 30, and this 0, and this is minus 20, and this is minus 9, so this is minus 30, and this becomes plus 30. So this also entry will become 0, and ultimately you show that all entries are 0. So this is equal to RHS. So this part we have done. Now the next part is that find A inverse using that equation. So we'll write that equation again. A cube minus 6a square plus 9a minus 4i equals to 0. Now we multiply. First we post multiply both sides by A inverse. So you should get A inverse in any of the in this equation, and from there you will take rest of the A inverse, you'll keep it at one side, left hand side, rest you take to the right hand side. So this becomes A cube into A inverse minus 6a square into A inverse plus 9a into A inverse, and this is minus 4i A inverse and 0 into A inverse. So you can see this A cube, it is you can write this A square, A into A inverse, this minus 6a can be written as A inverse, and this becomes 9i. A inverse exists. We have to initially we have to verify this whether A inverse exists or not. So we determinant of A you calculate, and then you can, but in this question if they are saying that find A inverse, it means it's very clear that inverse existing, otherwise they will not ask this question. So no need to calculate determinant of A. You will get it here somehow. 9a, this is 4a inverse equal to 0 matrix. So this 4a you take to this side and rest let it be there. So this becomes A square, this is 6a, and this is 9i, and this side you take this as 4a inverse. So we'll solve this side, A square minus 6a plus 9i, and after this we'll take 4 to the denominator and we'll get A inverse. So we'll continue on the next page. So A square we have found. A square is, we'll write this, A square is 6 minus 5 minus 5, 6 minus 5 minus 5, this is 6. So this is A square, and 6a will multiply directly, 6 to the 12, this is minus 6, A is here, A we have already seen 6a, then this is 6, and this is minus 6, this is 12, this is minus 6, 6 minus 6, this is 12, and 9i will be 9 0 0 0 9 0 0 0 9, and this is equal to 4a inverse. So now we'll continue from here. 4a inverse, so simplify this side, this 6, this is minus 12, and this is 9, so 6 9 15, 15 minus 12, this will be 3, this is minus 5, and this is minus plus 6, so and this is 0, so minus 5 plus 6 it becomes plus 1, so answer is 1. This is 5 and this will be minus 5, so answer will be minus 1. Minus 5 and this becomes plus 6, so answer will be 1. 6 and this is minus 12, or you can say 6 9 15, 15 minus 12, 15 minus 12 is 3. Next is minus 5, this is plus 6, minus minus plus 6, so plus 1. 5, this is minus 6, so answer is minus 1, and minus 5, this becomes plus 6, So minus 5 plus 6, answer is 1. And then 6 at last, 6 and 9, 15. 15 minus 12, this answer is 3. So this is for A inverse. Now A inverse will be, you divide this by 1 by 4, 3, 1, minus 1, 1, 3, 1, minus 1, 1, 3. So now we have got the answer, but you remember that whether this answer is correct or not, we should verify. So how we can verify? You multiply this A inverse by A, means this A inverse, if you multiply by A, your answer should be I. So I'll also do the checking. If my this is fine, that means this answer is correct, and I at least save the 4 marks. Why I'm saying you to go through? Because this will save your 4 marks. There are many calculations, or you might have done any calculation wrong, so better you just verify. It takes few seconds. See, when we verify, there is no need to multiply the whole two whole matrix, this one and into this one. So this simple way will let you know whether your answer is correct or not. So simply this checking method I have explained you in previous exercise, but I did not do any question. Now I'm doing this. So this is R1 into C1. This is A inverse including 1 by 4. If you take 1 by 4 inside, then it will be 3 by 4 into this A. You can see this is A, and now you multiply. So this row 1 means 3 into 2, 1 into minus 1, and minus 1 into 1, and this 1 by 4 is outside, so take it in the denominator. So this answer is coming, this is 4 upon 4, the answer is 1. So now take R2 C2. R2 C2 means this R2, 1 into minus 1, 3 into 2, and 1 into minus 1. So this answer is also coming 1. Now R3 C3 means this row R3, this minus 1 into 1, 1 into minus 1, and 3 into 2. So this is 3 into 2, 4. So this is now also coming 1. So if you get these three elements as 1, 1, 1, it means your answer is 100% correct. There is no need to multiply each and every element and to know whether this answer is correct or not. Okay, now come to these two MCQs. Though I could have given you for the homework, but I felt like I should be discussing this question now, because these are very, very important types. First one is, let A be a non-singular matrix of order 3 cross 3, then adjoint of A is equal to. So you have done a result which I explained you in the previous class also, that adjoint, determinant of adjoint equal to determinant of A n minus 1. So this property or this formula I gave you in the last class. Basis on that, you can see adjoint of A will be, here n is 3. So this will be 3 minus 1, this is 2. So this answer B is correct, A square. Now come to this, if A is invertible matrix over the 3, then determinant of A inverse you have to find. So you see that A inverse is actually 1 upon determinant of A and adjoint of A. So now you take determinant both the side A inverse. This will be then you can take determinant of 1 upon determinant of A, and this is adjoint of A. So remember this, now this determinant of A, which is this one, determinant of A is some scalar, and this scalar means some k. I give you a result, you have done this result, that determinant k determinant of A equal to k n determinant of A, where A is of order n. So this result here, this k is actually this constant. So apply this result. So your answer of this will be, the order is, you can see the order is given 2. So this will be determinant of A square. This is k, remember this is k, and this will become adjoint of A. So now adjoint of A, you have seen this in previous part, that adjoint of A, determinant of adjoint A is determinant of A n minus 1. So this will be ultimately 1 upon determinant of A square into determinant of A 2 minus 1. So 2 minus 1, this is 1. So this will be 1 upon determinant of A only, or you can say this is 1 upon determinant of A. So your option number B is correct. please you may ask again if you have not understood this way, right? But this is very very important, please keep in mind.